Hello, in this video we're going to go over the problems from Algebra 3B, graphs of trig functions. So when we graph trig function like this, 3 times cosine of x plus pi, first we need to label all the information from the given equation. So first, what is amplitude? Amplitude is absolute value of this number that multiply, in this case just 3. What is period? Period is this number multiplied 2 pi over that number, in this case 1, so we do 2 pi over 1 gives us just 2 pi. That means this graph repeats every 2 pi. Phase shift, which is horizontal shift, in this case will be x minus negative pi, so it will be left to pi, so pi to left amount. And midline, which represents vertical shift, there is none. There's no number added or subtracted here, right? So midline is just y equals 0. So first we need to find these. Then our next step is to come up with primary points. So what are primary points? So these are just key points on the graph that could help us sketch the transform function. So primary points, the way we find it is always the period, whatever the period of the function, divide by 4. So we always divide by 4. And I'll tell you why in a second. So for this example, our period is 2 pi. So 2 pi over 4, then pi over 2. That means what happens here is when we label the x-axis, we can increase by, we start from 0 and we increase by pi over 2. Again, this is just a guide. So add 2 pi over 2, which is just pi. Then we get 3 pi over 2. Then we get pi. Oops, sorry, 2 pi. So this is one period. So from 0 to 2 pi, the graph will repeat. Has same shape every 2 pi. Okay. So the reason why I divide 4 is so that we can have 4 different sections. And these 4 sections, in this case, represent 4 different quadrants of angle measure. But sometimes it appears not 2 pi, it doesn't. Okay. So we'll sketch this first, then we look at amplitude. Amplitude is 3. That means we go up all the way to 3 here and go down all the way to negative 3. Okay. So let's plot some points using these primary points. We know this, the cosine has shape of something like this, starting at 0. So cosine, we use this 5 points. And we know cosine has shape of something like this. Make sure to draw a curve. They're never a straight line. And again, it repeats. But we're not done yet. This graph right here is only applied amplitude, period, and midline. We haven't applied the phase shift yet. So for phase shift, for each point, we can reference this each of these 5 points, 5 point, go left to pi amount. So let's mark some x-axis on the left, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So let's look at this point. Now this point is 0. Since it goes to negative pi, we go negative pi 1. So this point will be now here now, right here. So this is pi to left. Now this point right here, we'll go to negative pi over 2. This one will go pi So we go to 0, since we're going to pi amount. You see the pattern. Now 3 pi over 2. Now this one will go right here. And this one, 2 pi, will go to pi. So with this new 5 3-points, let me highlight these. With these 5 new points after phase shift. So let me draw the final graph. Again, the shape is same, where it curves like this for cosine. And again, it repeats. We only draw one period, because after we draw one period, it just repeats. So usually it's okay to just draw one period as long as you draw an arrow. Okay. So this purple graph, make it thicker maybe. This is the final answer. Okay, so let's look at another problem. Now that I went over that one, I'd like you to pause this and try this on your own first. Okay. Then when you come back, of course, I'll go over it. Okay, so let's see. This one, we can also write it, if it's more comfortable for you, plus 2. So we know that amplitude is just 1. There isn't any number multiplied in front of sign, so amplitude is just 1. Period is 2 pi is always 2 pi divided by whatever this number is. So it's 2 pi over 3. If I simplify that, I get just 3. So period is 3 radian for this example. There's no phase shift. Let me just write phase shift. Phase shift none. Midline. The midline, we added 2, so that means y equals 2 is the midline of this graph. So again, it's also helped to kind of sketch the generic shape of sine, which is this, right? Each period. Just keep that in mind because we'll need that. So now let's similarly find the primary points. Let me just write primary points. There's always the period, in this case 3, divided by 4. So in this case, just 3 over 4. What does that mean? That means that when I label the x-axis, it's helpful to label by 3 over 4 at a time. 6 over 4, 9 over 4, 12 over 4. 12 over 4 is 3. And this 3, this number should be same as a period. It's not coincidence. So basically, we're dividing each one period into 4 different sections. Now let's label the y-axis is 1, 2, 3, 4, -1, -2, -3. Now here, midline is 2. That means that entire function will get lifted up by 2. So we can think as this is the y-axis now. Sorry, x-axis. Okay. So let's plot some points. So before we actually apply to y-axis, if you can do it right away, that's fine. Applying the vertical shift. But if you can't, just do what I do first. So we know that amplitude is 1. So the graph we have at the moment is just sine graph has shape of this. Like this shape, right? But amplitude is still 1 because maximum 1, minimum 1. then we're going to shift the entire graph up by 2. That means this point right here go up 2 right here. Let me use different color. This point go up 2. Up 2. Up 2 right here. So our final graph is this right here. But again, this just, we only draw one period. Always draw an arrow unless it's restricted, or we can just dot it and show that it's repeating. This is very important fact to remember, because angles, each angle has a infinite number of coterminal angles. So graphs repeats forever. That's a very unique characteristic of sine and cosine and tangent graph. Okay. Let's go next page. Same idea. Pause the video, try on your own. It's one of those things that you individually need to practice to be able to graph this on your own. Okay, so make sure to try this. Pause the video, try on your own, and come back. Oops, sorry. Okay, so let's try this. So what is amplitude? Amplitude is absolute value of -2 equals 2. Now this one, actually, I'm going to point out early, and you also should mark it. The negative means reflect over x-axis. So that's important. Is write it down so they will not forget to do that when we graph it. What is the period? Period will be 2 pi divided by this number right here. Okay, which is 4, which is pi over 2. So the period got a lot smaller, right? Usually this regular sine function period is 2 pi, and now this is pi over 2. Now phase shift. If there's a phase shift, we need to be able to write in different form first. So let me write it. This one. We can write it -2 sine. We're going to factor 4 out. X plus 2 pi over 4 minus 1. So this tells us that phase shift is left to pi over 4 amount, which is same as pi over 2. So pi over 2 to the left. And another way of thinking of phase shift is, what do I need to plug in for x right here to make this inside 0? And there will be negative pi over 2. That tells us that this phase shift is pi over to the left. So let's look at midline. Is y equals -1. Okay, so we found all this essential information. Let's find the primary points. Again, primary points are just a tool for us to help us sketch this graph. So primary points are always the period, which is pi over 2, divided by 4, which gives me pi over 8. That means when I mark x-axis, it increased by pi over 8 at a time. For 2 pi over 8, 3 pi over 8, 4 pi over 8. And as you can notice, 4 pi over 8 is same as pi over 2, which is we got as period. Okay, that's good. Then let's label the y-axis. 1, 2, 3, negative 1, negative 2, negative 3. Okay, so that actually, I know I didn't write in previous, but let's actually do write the numbers. Okay. Let's also label negative directions. Since there's a phase shift to the left, that means we might have to be using the other side of y-axis. So this is same as negative pi over 2. So let's plot some points. Well, so actually I'm going to draw a midline first, y equals negative 1. That means entire graph will go down by 1. So remember the sine graph has shape of like this. So the original shape would have been with this period, with this right here. Again, it's not straight line. Make sure that it's curved. So we go down 1. So we move all the points. So we're moving all the points, but this primary points help us navigate better. So go down 1. So all these are here. Down 1, down 1. So this is after vertical shift right here. This green part right here is after vertical shift to down 1. Now let's do phase shift pi over to the left. Okay. So that means each point goes to pi over to the left. But the entire period is also pi over 2. So what actually happened to happen here is that this point goes to here. This point goes to here. This point goes here. So this is after the phase shift. But in this case, actually phase shift didn't make any difference because it repeats this anyway. Okay. So phase shift didn't make any difference here because phase shift and period are same numerical value in this example. Okay. So both green and purple, these two colors graph represent the same function, just at a different location. Okay. But just to avoid confusion, let's keep work with the purple one. Let's say we did move left pi over 2, although it's just identical. Now one last step. Again, this is one easy to forget. We reflect over x-axis. Okay. Oh, actually, I forgot one other thing, right? Amplitude. So as you've noticed that, order, the first thing we have to do is period and find the period points, primary points. After that, order doesn't really affect that much, right? So actually here, before I do reflect, I'm going to change the amplitude. So from here, the maximum is 2. So from here, you go up 2. So from midline, it should be up 2. From midline, it should go down 2. So the blue graph will show amplitude changed. So as you can see, the minimum and maximum value changed, right? So this blue graph is after the amplitude has changed. Now let's reflect over x-axis. I'm running out of color. Oh, I guess I haven't used red yet. So reflect just means that this point become negative. Well, will reflect over now this line right here, because y equals -1 is behaving like a y-axis, x-axis, sorry, x-axis. So this point stays same. This one becomes right here. This one now goes to here. This one stays the same. So this will stay the same. This red part is the final graph, and of course it repeats. I'm only doing that dash line here to show that you don't have to graph all of it. You can only show one period and just draw an arrow. So final graph, I know it's messy. This is the final graph. That's what the final graph. So it is helpful to check. I've done this part. I deleted the period. Period is the first thing actually get changed because of primary points. So working with primary points automatically changes the period when we graph it. Phase shift good. We took care of that, and midline. Okay. Tangent. Negative tangent of power 5. So tangent is a little different because shape is different and period is also different. Okay. So for tangent graph, the first thing you have to remember is that when we tangent graph has shape like these, and there's vertical asymptote, repeating. So that's the important thing to remember. Okay. So let's find we're going to find actually domain for these problems. Okay. So for domain of tangent, we have to exclude some values. So pi over 2 times b. So let's find this number first. So here we have, oh sorry, this is also pi over 5 theta implied here. So sorry, not implied, this typo. It should be negative tangent pi over 5 times input value, theta or x. So we have pi over 2 times 5 pi over 5. And if we simplify that, we get pi times 5 over 2 pi. We get 5 over 2. Okay. So for tangent graph, again, the way we graph is a little different because it has vertical asymptotes. So we cannot have certain angles. So this tells us the restrictions, the angles we cannot have in this transformed tangent graph. So 5 pi over 2 is a radian. So I have 5 pi over 2 and odd number multiples of 5 pi over 2. So let's multiply 3, then I get 15 over 2. Let me draw somewhat of scale. 15 pi over 2. 15 over 2, sorry. There's no pi here. And also multiply -1. We get -5 over 2. And maybe -15 over 2. So these here we have vertical asymptotes. So keep that in mind. So we cannot have those angles, because if I input 5 over 2 to this function right here, you will give me a tangent as undefined. Okay. So then we're going to sketch tangent graph using this vertical asymptote. So 0 is 0. So that's this shape. Draw an arrow, get it identical. Okay. So these are the same shape. Now one more important thing. Here's negative, right? That means we have to reflect over x-axis. So if we just like this. That's it. So they earn as many points to plot, but we start with domain of the function. What values should we exclude? Right? Okay, let's look at the last problem. Again, pause this, try on your own, and come back. So this tells that we have a cosine function. So a of cosine bx. So it's the amplitude is 4. That means that a can be plus minus 4 because amplitude we take absolute value. And period is 6 pi. That means that 2 pi divided by b gives me 6 pi. So we already found a. What is b? Let's solve for b here. Let's multiply by b both sides. b equals 2 pi over 6 pi, which is 1/3. So here we actually have two possible answers. One is negative 4 cosine 1/3 x, and one is positive 4 cosine 1/3 x. And if there was a vertical shift or midline y equals, let's say, positive 2, then we just plus 2 in both equations.